In this video, you will learn how to draw free body diagrams. Free body diagrams are used to visualize the forces acting on an object. Let's jump right into some examples. First, we have a box which is being pushed across a rough surface. To start drawing your free body diagram, you want to draw the object, which in this case is a box, as a single point. And then you need to think, what forces are acting on this object? Well, we know the force of gravity is pushing down on this box. And because the box is sitting on a surface, there will be a normal force, which represents the surface pushing back on the box. And this normal force is perpendicular to the surface. And we also know the person is pushing on the box. So we will draw a vector for the pushing force. And this vector is in the direction that the box is moving. And finally, we were told that the box is moving on a rough surface. That means there will be some friction between the box and the surface. So we have to draw the friction vector. And friction is always opposing the object's motion. So it will be to the left. Next, we have a car that is driving along the highway. Again, we represent the object, which is the car, as a single point. And then we have to ask ourselves, what forces are acting on this object? We know the car has an engine, so that would be a thrust force, and we can draw that pointed to the right because the thrust force will always be in the same direction as the object's motion. And because the car is driving along a surface, there will be some friction between the car's tire and the road. And now we also know gravity is pushing down on this car, and the surface is pushing back up on the car. So we draw the normal force vector. Let's move on to the third example. Here we have a skydiver who is flying through the air, and they're falling down because gravity is pushing down on them, but they also face some air resistance, so there's a drag force that is pushing up on them. Finally, we have our last example, which says a sled is being pulled by a rope at a 45-degree angle. And we know because there's a rope that we're going to have a tension force. And we will draw that tension force at a 45-degree angle because the rope is being pulled at a 45-degree angle. And then we have to draw the gravity vector because the force of gravity is pushing down on the sled. And because the sled is moving along a surface, the surface is pushing back up on it. That's the normal force. And we can also assume that there's going to be some friction between the surface and the sled, and we can draw the friction force just like this. And that's the end of our discussion on free body diagrams. Now I really want to emphasize the importance of these free body diagrams. They may seem like simple visualizations, but when you have to actually answer questions and do problem solving using forces, it really helps to be able to visualize all the forces acting on the object and to be able to see what direction the net force will be. And if you don't understand what net forces are, that's okay. Go check out my video on net forces and how you can solve for the net force acting on an object.